All right, y'all, so we're still in 8.4. So we're going to pick up with example number 10. And on this example, they want us to find a polynomial function of lowest degree. So find a polynomial of lowest degree with zeros of -4i and 5. Okay. So here's where they're being sneaky. They're saying lowest degree. They're not telling me the degree because they don't want me to really know right offhand how many zeros I should have. They want me to look at these zeros they gave me and figure out if I should have any more zeros. So if they give me a zero of -4i and 5, this zero, since it's imaginary, the other day we said imaginary zeros have to come in conjugate pairs. So if they give me two zeros like this, then let me let one in real quick. Then that means 4i must also be a zero. Okay, just like on the radicals, if I would have gave you a radical like square root of 5, then negative square root of 5 would also be a zero. Okay, so now they actually want us to go further and find a polynomial. So since we have 3 zeros, when we're done, we're going to have a degree 3 polynomial. So we always started out with setting these equal to 0. And I always put that single number up front because when I FOIL, I'm going to FOIL these two first and then multiply them by that one, okay? So we need zeros on the right side because we got to work these in reverse. So if you notice, this is totally reverse of having to solve these, okay? So then add 4i to this one. And then subtract 4i from our last one. All right, so remember the next step working in reverse would be to put all 3 of these factors inside parentheses and still set them equal to 0. So we would put x minus 5, x plus 4i, x minus 4i in parentheses equal to 0. So this would be what we would consider the factored form of that polynomial. So now we're going to go from factored form into polynomial form. So we got to start FOILing. So you always want to start with these conjugate pairs of imaginary numbers when you FOIL. Okay, so on the side, we're going to FOIL x plus 4i and x minus 4i. Remember, since these are conjugate pairs, the i's are going to disappear when we get the final product, okay? So we would do x times x and get me an x squared. X times -4i is a -4i x. On the inside, I got positive 4i times x, so that'll be a positive 4i x. And then at the end, 4i times -4i gives me a -16i squared. So the first thing I want y'all to notice, the middle 2 terms cancel. And the middle 2 terms always cancel when you FOIL conjugate pairs. So here's a question. I need to replace that I squared with something. So do y'all remember what the I squared has to equal? So let me get my chat up. All right, so good job, y'all. It's actually -1. So yep, so remember it's a -1 on that, okay? So replace the I squared with a -1. So that's just going to turn the -16 I squared into a positive 16. So this will end up as an x squared plus 16. And y'all watch this. Let me zoom to my calculator real quick. And let me go back to the regular screen here. So you got an I on the calculator. There's a little blue I above the decimal. So if you'll push the second button and the decimal, that puts the little I on your calculator. And then just hit the x squared button to square it. So I got I squared on my calculator. When I hit enter, I get -1. All right, y'all, so let's go back to the pad. So yeah, if you ever want to do the I's on the calculator, it will do those, okay? So here we go. Bring down to x minus 5. In these parentheses, I now will put the x squared plus 16, all that equal to my 0. So my side work, I threw in my second parentheses. All right, so now we got 2 sets of parentheses, which wants me to multiply again. So once again, I'm going to FOIL this one. Now, since these are the last 2 things I'm going to FOIL, I'm just going to FOIL them right here and then simplify, okay? So y'all, here we go. X times x squared is x to the 3rd. X times 16 is 16x. -5 times x squared is a -5x squared. -5 times 16 is a -80. So the only thing I would probably do to this problem is put these answers in descending order. So go with your highest exponent down to the number, okay? So I would do the x3 minus the 5x squared plus the 16x minus 80. And y'all remember, all Math Lab wants is your little polynomial, okay? All right, so let's try number 11. Same thing. We're going to find a polynomial of lowest degrees with zeros. So we're given zeros of square root of 3 and 3i. Find a polynomial of lowest degree. So y'all, here's a question for y'all. If they're giving me them 2 zeros, those both come in conjugate pairs. So we got to have more zeros. So what are they?
-3i.
Oh, what was that?
-3i.
-3i. And?
What's that? The negative square root of 3?
Negative square root of 3. That's what we wanted right there. Good job. So I'm going to put my radicals together in my answers and my imaginary. So these must also be zeros. All right, so I'm going to move my camera down a little bit so we can get the rest of this. So that means x equals a square root of 3. X equals a negative square root of 3. X equals a 3i. And x equals a negative 3i. Soon as we won't simplify that poly up there, No, this one right here, if you notice, the reason I can't go no further because I don't have any more like terms. So my x3s won't add to my x2s or my x's or my single number. So at that point, if I did any factoring, I would go back in reverse. Okay. So there's no like terms and we don't want it to go in reverse. Okay. All righty, also on here, add and subtract, get everything on the other side. So subtract square root of 3 from the first one. Add square root of 3 to the second. Subtract 3i. And then finally add 3i. So see, they're being sneaky now when we find these polynomials because they're only giving us some of our zeros and we got to know there's more. So guess what? We have 4 zeros here. We better end up with an x to the 4th as our highest exponent, okay? All right, y'all, so put all these factors in parentheses. So now what I'm going to do on the side, I'm actually going to FOIL these two together. And I'm also going to FOIL those last two. Because both of these we have what we call conjugate pairs, okay? So I'm going to FOIL these two together and these two together. So then we'll have 2 more sets of parentheses with their answers. So on the side, I'm going to do both of those. So here, x minus square root of 3, x plus square root of 3. Over here, I'll do the x minus 3i, x plus 3i. All righty, y'all. So x times x is x squared. X times square root of 3 is a positive square root of 3 times x. Negative square root of 3 times x is a negative square root of 3x. And then a negative square root of 3 times a positive square root of 3 is a negative square root of 9. So since the 3's are both under radicals, you can multiply them together, okay? And keep it under the radical at that point. So now, the middle 2 terms cancel. And remember, we said they would every time we had conjugates. So I'll bring down that x squared. This is going to be minus square root of 9, which gives me 3. But y'all, that goes back to that, what we said yesterday. A square root of 3 times the square root of 3 in the long run gives me a 3, okay? So I would put that in my first parentheses. Now, these are conjugate pairs of imaginary numbers, so they're going to cancel also. X times x is an x squared. X times 3i is a 3ix. Negative 3i times x is a negative 3ix. And then negative 3i times 3i is a negative 9i squared. So x squared minus 3i. Oh, you're so close, but notice these 3 i's aren't in radicals. So I wouldn't have to actually take their square root. So watch, it's actually going to be x squared. The middles cancel again. But remember this, what does I squared equal? Remember, it equals -1. So since I squared is -1, all that's going to do is make that -9 into a +9. Remember, you still don't want to take square root on that because it's not under a radical, okay? So remember, I don't have that. All I have is just a 9. There you go. All right, y'all, so the x squared plus 9 goes into the second parentheses. So now it looks like all we got to do is FOIL these last two parentheses and be done. So notice, we like to make y'all FOIL sometimes. So I'm going to pull that down so I can FOIL. X squared times x squared is an x4. X squared times 9 is a 9x squared. Negative 3 times x squared is a negative 3x squared. And then negative 3 times 9 is a negative 27. Technically all equal to 0. So let me ask you this. The one I did earlier, I couldn't go no further. Can I actually go further on this problem?
Yes.
Yes, because right there in the middle, those x squareds will add together on this one. So we end up with what, an x to the 4. What's that? 9 minus 3 will leave me 6 x squareds minus my 27 equal to 0. So Math Lab, like I said, I want that polynomial. And y'all guess what? We had 4 zeros up here. We ended up with a x to the 4th. All righty, so now we get back into our synthetic division. So y'all let me flip over. And this one will be like y'all's number 12. So I'm gonna have to move this back up. Let me move this out of my way real quick. All right, so now we're going to find zeros, and we're going to find zeros by using synthetic division. So in the beginning, they're nice and they help us out by giving us some of these zeros. So the function has the given 0. Find the other zeros. All right, so my function is this: f of x equals x to the 3rd plus 4x squared minus 5x minus 20. And then they got a semicolon, and the 0 they're giving me is negative 4. So they're giving me my polynomial, and then they're giving me the 0 of negative 4. So what that means, my first C when I do my synthetic division will be negative 4. So what we do, we're going to use synthetic division and divide this number out, that negative 4. Once we got that negative 4 divided out, we're going to take that quotient and find remaining zeros, okay? So to do synthetic division, we write out our coefficients, which is a 1, 4, negative 5, negative 20. You always have one more coefficient than the highest exponent. So since that was a 3, that means I needed 4 numbers. And notice I didn't have any missing exponents, so we were good to go. All right, then we draw our little box under our numbers. And remember, leave space in here because we're going to eventually be writing numbers in that space, right? Now, check this out. If they're giving me a 0 of negative 4, what will my remainder be when I do my synthetic division? Because remember, there was one thing I had to get for a remainder in order for these to be a 0. And good job, it has to be a 0. So if they give you a 0 and you don't get a 0 here, you made a mistake in here, okay? All right, y'all, so remember, synthetic division, we bring that first number down. Now to get the next column, we take the number here, multiply by our C. So 1 times negative 4 is -4. Add the column to get the next coefficient down here. So 4 and -4 gives you a 0. Now repeat the process. 0 times -4 is 0. Add that column to get your next coefficient, which is a -5. And y'all finally, -5 times -4 is a +20. And when you add those up, you will have a 0. So -4 is a 0 no matter what. Now y'all check this out. Since we're down to 3 numbers as our coefficients, this is like an x squared plus a 0x minus 5, because your coefficient always starts out 1 degree less than your original polynomial, which was a 3. So that meant our coefficient member started out 1 degree less. But since we're down to 3 numbers, we can use the quad. A would equal 1, B would equal 0, C would equal -5. Either use the quad or try to solve that using the program on your calculator. So most of y'all got the program, right, that I sent you? So I would show you, I would go to my calculator. So remember, on the calculator, you would go to the program button. Whoops, I don't have that on this one, my bad. So let me go back. I guess I'm doing this by hand, right? All righty, so I'm gonna show you a trick. That's like an x squared plus 0x, which I don't have to write, minus 5. So watch this. I don't even need the quad on this one, because since it's an x squared and a number, since I got a 0 in the middle, I can just solve this using square roots. So to solve by square roots, I would add 5. Then take square roots of both sides. And remember, since we're taking the square root of a 5, we got to use our plus or minus, remember. Because remember, radicals always come in conjugate pairs. So that we get x equals, y'all, we can't do nothing to that square root of 5. So that'll just be a plus or minus square root of 5. But let me show you on the calculator. So I think y'all can see this one. So let me go to program, down to quad. So y'all should just have the quad that I sent. So you would hit enter and enter again. A, you would put 1. B, you would put 0. C, we would put -5. Now remember, I don't want decimals, so I hit enter one more time. And it gives me 0 plus square root of 5, 0 minus square root of 5, okay? So since those first numbers are zeros, you don't have to write those. So our other zeros would be square root of 5 and negative square root of 5. All righty, so one more of those and then we'll move into another topic. So for 13, they're giving us same thing. They're giving me 1, 0, and I'm going to use that 0 to find all the rest. So y'all, our polynomial this time is f of x equals x to the 4th plus 55 x squared minus 576. Then they got a colon, and the 0 they're giving us, ain't I, is a 0. So y'all about to have fun with some imaginary numbers. Guess what? That's an x to the 4. I can't use quad till I get it down to an x squared. So I'm going to have to use synthetic division twice to go from 5 numbers down to my 3 for the quad, okay? So y'all, I'll tell you what, I'm going to give y'all the first C, which is 8i. What I need is the coefficients. So guess what? My first coefficient is a 1. So what's next?
55.
Oh, no. I see it on the screen, a 0. You remember why I need a 0? Because here's an x4. This is an x squared. But since I don't have an x3 term here, we got to put a 0 as a placeholder. Then we do have the x squared term, which is 55. So what would be next? Oh, I got Zach on that one. So Zach, you won't have to make another guess. Oh, I got it. Zeros. Perfect. Zeros because you don't have an x term sitting there, remember? So since I don't have the x, so see, you don't have that there, and you don't have an x there. So they're both zeros. And then I'm going to put negative 576. So remember, y'all, since that was a degree 4, you add 1 to that, that means you need 5 numbers. Now, since they told me 8i's are 0, my remainder has to be 0 when we're done. Well, y'all, so here we go. This ain't too bad. You bring that 1 straight down. All right, 1 times 8i, that's 8i. 0 plus 8i, well, that's 8i. So y'all, here's the tricky one. 8i times 8i. What do you think that gives me?
64. I
64i squared, right?
Yeah, was that said?
But I'm not going to put 64i squared here because don't that simplify a little bit further?
This
What does that I squared equal?
-1.
So that's going to make that 6. That's going to make that positive 64i squared into a negative 64, right? Remember, if you got a 64i squared, yeah, since that 64 is positive, that I squared turns that thing into a negative 64. All right, y'all, here we go. Negative 64 and 55 gives you a negative 9. Negative 9 times 8i is a negative 72i. All right. 0 plus negative 72i is a negative 72i. And y'all check this out. Negative 72i times 8i gives you a negative 576i squared. So what is that really going to give me there?
A positive
576. There you go. So see, y'all getting used to my I squareds now. Because we knew it had to be that, because remember that remainder had to be 0. So y'all, here's the issue with this one. I still got 4 numbers in my quotient here. So since I still got 4 numbers, this is like an x3 plus an 8i x squared minus 9x minus 72i. So since I still got 4 terms, I'm going to use those 4 numbers and do my synthetic division again. Oh, y'all, guess what? They only gave me 1 0 up here, 8i. So we're sort of stuck on what number to put. Oh, y'all got it. Y'all got it. Good job. Negative 8i, right? Because they always come in conjugate pairs. Well, y'all on the road tonight. So We'll have to turn it up, I guess, in a little while. All right, y'all. So let's run through this. So we know we better get a 0 here. So here we go. Bring down our 1. There you go. That's what we want. Right, y'all. So 1 times -8i is a -8i. Add them together. That's a big 0. 0 times -8i is 0. -9 and 0 is -9. And then we got a -9 times a -8i. That makes a positive 72i. Well, guess what? Those do give me a nice 0. So since we are now down to 3 numbers, we can use the quad. You would do 1, 0, -9. I'll solve that real quick using square roots again, because remember, that's like an x squared minus 9 equal to my 0. I can add 9. And then take those square roots again. That's going to be a positive or minus square root of 9 on this one. So it looks like this one actually gives me nice numbers. I'm going to get what, a plus or minus 3. So the actual other zeros we had to find was that -8i, and then 3 and -3. Okay, but y'all notice, up until now, they're giving us numbers to use for the zeros. So we're about to learn is what we do if they don't give me any numbers for my zeros. Okay, so let me see if I'm got this right. All right, so this, what we're about to find is what we call finding all possible rational zeros. Remember, rational numbers are numbers like fractions. So we're not worried about the imaginary stuff or the radicals, but this will tell us how to find all of the possible rational zeros, okay? So to find all possible factors, we find all possible ratios of P over Q. And that's going to be a plus or minus in the front of these, okay? Where P is factors of last number. So the last number of the polynomial, I find all those factors, and those will be my P's. The Q is factors of the first number, which is often called the lead coefficient. Okay. So the last number is that constant term. It's the number that don't have a variable. And then the first number is always the one in front of the degree, okay? So you got to find all factors of P and divide by all the factors of the Q to get all possible zeros. They're not going to be all zeros, but it gives you a list of all the possible zeros, okay? Now, let me show you an example. So look at this. This will be, I guess, like y'all's 14. Find all possible rational zeros for the polynomial function. So y'all, they're giving us P of X equals 14x to the third minus 34x squared plus 42x minus 15. So remember, P is the factors of the last number. Q will be the factors of the first number. So since P's on top, I'm going to find all factors of my last number, which is 15. So the all possible factors of 15 would be 1, 3, 5, and 15. Right, so 1 times 15 and then 3 times 5. All the factors of Q, Q is 14, it's my first number. All the factors of 14 would be 1, 2, 7, and 14. So y'all with me so far? P is the last number, find all those factors. Q is the first number, find its factors. Now, my possible factors, here we go. So I take all these factors of the P, 1, 3, 5, and 15. I'm going to take each one of these 4 numbers here and divide by all 4 of these numbers. So I'm going to do 1 divided by 1, 1 divided by 2, 1 divided by 7, 1 divided by 14. Then I'll do the same thing with the 3. 3 divided by 1, 3 divided by 2, and so on. So let's start with the 1. Remember, these can all be plus or minus. So 1 divided by 1, 1 divided by 2, 1 divided by 7, 1 divided by 14. Now, do y'all notice if any of those will simplify, we got to simplify it. So I do have one of these that'll simplify further, and that's that 1 over 1. I could write that as a plus or minus 1. Okay, so when it divides out, simplify it. All right, so that takes care of that factor. Next, we do that with the 3. That's my next P. So I'll have plus or minus 3 divided by 1, plus or minus 3 divided by 2, plus or minus 3 divided by 7, and then plus or minus 3 divided by 14. Once again, plus or minus 3 over 1 will reduce to a plus or minus 3. So notice I've already got 2, 4, 6, 8, 10, 12, 14, 16 possible zeros. They're not all zeros, but these are the numbers that would be the zeros, okay? All righty, 2 more to go. That takes care of the 3. So now we do the 5. Plus or minus 5 over 1, plus or minus 5 over 2, plus or minus 5 over 7, plus or minus 5 over 14. And I'm going to make that what? A plus or minus 5. So that takes care of 5. And the last one is our 15. So plus or minus 15 over 1, plus or minus 15 over 2, plus or minus 15 over 7, and then plus or minus 15 over 14. And y'all, once again, this would be what? A plus or minus 15, okay? So I have like 32 possible zeros. So if I was to start checking these numbers, I'm guaranteed that some of these zeros are going to be in these sets of numbers, okay? Now, that one didn't want me to find any zeros. They just wanted me to find any possible zeros, okay? Now, I ain't gonna lie. This is nice and handy if you don't have a calculator. But if you got a calculator, I graph those polynomials, and it's going to cross the x-axis at one of these numbers, okay? So I graph them to help me out when I don't get none given to me. So let me show you an example of what I'm talking about. So let me find a good one. Yeah, I'll try this one. So they want me to find the rational zeros. And then the other zeros. Of f of x equals x to the third minus 73x plus 72. Now, after I do that, for part B, they want me to factor into linear factors. So what they mean by that, they want us to sort of put them back into parentheses. All right, let me sign one in real quick. Where's she at? All righty. So notice if I was going to do the P and the Q stuff, P is 72. In Q, since there's not a number here, Q would be like a 1 in the front. So since I got a 1 in the front, basically my zeros are going to be any of these factors of 72. So factors of 72 would be like 1, 2, let's see, 3, 4, 6, 8, right? 8 times 9. Let's see, 6 times what? 12. 4 times 18. 3 times 24. 2 times 36. And then the 1 and 72. So one of these numbers, plus or minus, would be the possible zeros. So y'all, I don't want to sit and run synthetic division 1 and -1, 2 and -2, looking for a zero remainder. So let me show you a trick I do to these. If they don't give you a zero, we got technology. So we're going to go to our calculator, and we're going to go to y equals, and we're going to graph this thing. X to the third, so x exponent 3, bring that down, minus 73x plus 72. Now, when I graph this, I'm looking for the places that crosses the x-axis. I can also look at the table. In the table, I'm looking for any numbers that have y values that are 0, right? So to cross the x-axis means that the y's are 0 there. So let's see if we can graph this. Whoops, let me zoom back normal here. So I'm going to go to zoom, number 6, to put me back on a normal screen. All right, so look there. It's crossing right here. It's crossing right here. And it's crossing on the right. So it looks like the furthest left, that's what, -1, 2, 3, 4, 5, 6, 7, 8. Looks like a -9. That one looks like a +1. And then let's see, 3, 4, 5, 6. And the last one looks like it's at +8. But if you want to be for sure, go to the table, second graph. So look right here, I got a 0 for 72. I'm looking for Y value. So I thought that was, I'm going to do one thing. Let me set my table back. Remember I showed y'all how to do this the other day? I don't want that table set to be, I want it to start at -1. And I want that delta of the triangle table, I want that to go by ones now. So it's going to go by ones. So now when I go to my table, second graph. So there's a 0 at 1, like we said. Now, if I arrow up, we said that I think was -9 where it crossed. At -9, I got a 0, stop. And then the other one, if I go the other way, was I think what, +8. So there's that one at 8. So actually, since this one is easy to tell where it's crossing the x-axis, we basically already know all 3 of these zeros, okay? So let me go back to my pad. But let me show you what I would do. So by hand, here's what you would do. So since my first factor is 1, I would try a +1 and a -1. So my first C, I always try the positives and then the negatives. If that don't give me a 0 remainder from any one of those, I'll do plus and -2. If those don't work, I'll do plus or -3 and so on. I'm looking for a 0 remainder. So y'all, I need my coefficients. So what's the first coefficient?
1.
All righty. Second coefficient.
Would it be a 1? Would it be? Oh, Lord.
Oh, now I will say this. -73 is going to be my third coefficient. There you go. I need that 0. And that's because I don't have that x² term again. Then the -73, then the 72. So then draw the box. So we bring down a 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1 again. -73 and 1 is what? -72. And there we go. -72 times 1 gives you -72 for a 0 remainder. So at this point, you would use quad. A would be 1. B would be 1. C would be a -72. So let's see what quad does. All right, so I got a 1, 1, -72. And y'all, there you go. There's that 8 and that -9. So our other 2 x's are 8 and -9. Now, these are all rational zeros. So the answer you would pick, there are only rational zeros, and the zeros are blank. So then you would put in my first one, which was 1, my 8, and my -9. Then remember, it wanted me to factor these into linear factors. So that's going to be putting all these factors back into parentheses. And if you remember from when you had to find all these polynomials, these zeros or solutions always had opposite signs than the factors. So since that 0 is 1, my first factor would be x minus 1. This was x equals 8, so that factor will be x minus 8. And for the 0, x equals -9, that's going to be x plus 9. All right, so y'all, I'm going to show y'all more power out of your calculator. So this will be like number 17, okay? And this will be the last one I'm going to do with y'all for tonight. So we're going to do the same thing as we did up here. This time my polynomial is f of x equals 2x to the third plus 5x squared plus 50x plus 125. I'm going to find all the zeros of this, which once again, there's going to be 3 zeros because I got an x to the third. And then we will factor this into linear factors. All righty, so you could list all those possible factors of 125 and 2. So this would be my P, and this will be my Q. So factors of 125 would be 1, 5. Let's see, what else? 25. 5 times 25. And then what? 1 times 125. That's all of them, right? 3 5s. Okay. Now, over here's my Q. Factors of 2 are just going to be 1 and 2. So on this, we know our possible zeros can be a plus or minus 1 divided by 1, plus or minus 1 divided by 2. So that would give me what? A plus or minus 1. So that takes care of that. Next, I would do the 5, plus or minus 5 over 1, plus or minus 5 over 2. That one would give me plus or minus 5. All right, then I'll do 25, plus or minus 25 over 1, plus or minus 25 over 2. So plus or minus 25. And then finally, the 125. And then that reduces to plus or minus 125. So I basically got 2, 4, 6, 8, 10, 12, 14, about 16 zeros I can guess out of. So let's let that calculator graph this and see if we can see what we got. So, whoops, let me go back. Go to my calculator. I'm gonna go to y equals and clear this one out. So I'm putting that polynomial in there, which was a 2x to the third. All right, arrow that back down. Plus 5x squared. Plus 50x. Plus 125. All right, so I'm going to go graph it to see if it's coming across. I'm hoping it goes across to 1, 5, 25, or 125. Because those are the only kind of numbers I'm going to see on this thing. So I would hit enter. So I see where it's crossing over here. So look at it. There's -1, -2. That thing's in between -2 and -3. So y'all, since it's not on one of these numbers, watch on the table. If you go to the table, between -2 and -3, let's go back up there. It's not neither one of them numbers. Whoops. Oh, this thing keeps going. Come on back. My computer's touchy. All right, so between -2 and -3, you don't see any zeros. But remember, I can go to that table set. So second window to do my table set. Down here on this delta table, you remember I said if you had a number up front, you could make that fraction so that it'll show you all the possible answers. Well, we had a 2x3 up front. So since that's a 2 up front, I'm going to make my table 1 divided by 2. Because I need it to show me these halves, okay? So you notice on those numbers we came up with, plus or minus 1 and all that, The other numbers were all 5 halves, 25 halves, and so on. They're all in halves. So we're going to set our table up for halves. Then when I go to second graph to get my table, now that was up between 2 and 3. So I'm going to go in between 2 and 3 on these negatives. Oh, look at that. Right here in between 2 and 3, I got a 0 on the y value, and that's at negative 2.5. Negative 2.5 is the negative 5 halves 0, okay? So let's go back now. So we know by graph, we came up with negative 5 halves. Now, y'all, you can punch negative 2.5 on your calculator, turn it into a fraction, and it'll give you that, okay? So that means that's my first 0. So negative 5 halves would be the first number I pulled in. Then I would get my coefficients. 2, 5, 50, and 125. Hoping for a 0 remainder on that, right? All right, y'all, here we go. Bring the 2 down. Watch this. 2 times negative 5 halves. Well, you can multiply that right on your calculator. Well, let me finish that program out. Do that on your calculator. 2 times negative 5 divided by 2. You're going to notice the 2's cancel and you end up with a negative 5. Oh, perfect. You beat me on the calculator. There you go. And then 5 and negative 5 is a big 0. So what is 0 times negative 5 halves? That's a 0. 50 plus 0 is 50. So y'all, I'm interested to see, multiply this out and see what I get when I multiply that 50 times that negative 5 halves. So what y'all getting on that? I know what I'm praying y'all get. All right, perfect. Negative 125. I was happy to see that because I'm happy to see a 0 there, okay? If I didn't have a 0 there, I'd be in trouble. All right, now remember, last 3 numbers, I'm going to use quad. A equals 2, B equals 0, C equals 50. So I'm going to have to use this because it wasn't on my other one. So we go program quad. A was 2, 0, and 50. So since negative 5 halves was a 0, my last 2 are, look at that, they're imaginary. That's why we didn't see where they crossed the x-axis because they were imaginary. So those gave me what? X equaled a 5i and a negative 5i. So on this one, these are not rational zeros. So when you put this one in the answer blank, you would put there is only one rational zero of blank, and that's going to be that negative 5 halves. And the other zeros are well, that's going to be the 5i and the negative 5i. And remember, y'all, either use the plus or minus 5i, or you can use 5i comma negative 5i. So those are my 3 zeros, which is what I needed out of that because I had an x to the 3rd. So 3 zeros means 3 sets of parentheses. Now this one's sort of picky, so let me show you what they did to this. So first of all, I know this one would be what? X plus 5 over 2. For the 5i, that'll be net x minus 5i. And then the negative 5i would be x plus 5i. So MathLab is picky. They don't like this in a fraction form. So what they do is they factor the 2 out, which is the denominator, to the front, and they make this x plus 5, and then x minus 5i, x plus 5i. For some reason, MathLab is sort of picky about that too. Okay, so let's see. That takes us through 8.4. So notice it starts off a little bit of foiling, but they're using zeros that you got to know about the conjugates for. Then they hit us with synthetic division. They gave me zeros. And then y'all at the end, we sort of got to play with these possible zeros or graph them, okay? Because guess what? That 0 right there, I'd have probably went through the plus or minus 1, plus or minus 5, plus or minus 25. I'd have went through all the real numbers first. Then I'd have probably did the plus or minus 1 halves before I even stepped up to this one. So I might have done synthetic division 10 times until I got to that. Oh, so y'all saying why positive? Because remember, the zeros you have are always opposite in sign when you put them into the factor form, okay? In the part B of this wanted these to be in, it said factor into linear factors. That's what they wanted on that, okay? All righty, so let's see. Y'all, I don't have anything else. So y'all remember, next week, y'all have spring break. So any homework you're behind on, catch up on spring break. You can email me if you got issues, and I might be around where I can actually respond and stuff. I don't have a whole lot going on next week. So if you do have issues, let me know. And I guess I won't see y'all till whatever the Tuesday after next is. So any questions before we go? All righty, y'all. So I don't see anything. So have a happy St. Patrick's Day and a fun spring break. And I'll get this video out in about a couple hours, okay?
Happy spring break, everyone.
All right, you too.